All right, so thanks for coming, everybody. I was wanting to give you a talk about some of the stuff that I do to leverage LLMs for text augmentation and what I do topic modeling. A little bit about myself. My name is Ariel Gamiño. I work for a company called Athena Health here in Austin, Texas. I work specifically for an app called Hippocrates app that doctors and clinicians use to look up medical information, drugs, diseases, and conditions, and the number one medical app in the US. And I also teach a class at the University of Texas at Austin, the Macomb School of Business, through in coordination with 2U EDX, and it's a data analytics bootcamp that I teach, in which students come and learn about data analytics, Python, JavaScript, SQL, Tableau, and we do a little bit of machine learning. But my role in Athena Health is an AI machine learning engineer, and I've been doing AI for about 5 years, and I've been doing geek tech stuff for about more than 25 years. So I wanted to talk to you about some of the stuff that I do and kind of give you an idea of how I leverage data. And first of all, what is data augmentation? And data augmentation refers to artificially generating new data from existing data in order to expand the size and improve the quality of the data set. So it creates plausible new data that you can use and generate instead of having to collect data from scratch. And some common methods of data augmentation, specifically for computer vision, include like random crops or flips, rotations, and stuff like you see here, which is maybe you have an original image and then you change the texture, you change the color, you change the edges of it, and then you do maybe a salient map, which is kind of like marking it, and then again flip and rotate. And for natural language processing tasks, augmented data might be generated through either paraphrasing something, saying it in another way, random insertions of text, synonym replacement, or leveraging trained large language models, which I'll show you in a moment. But overall, data augmentation enables you to use trained machine learning models with more robust data and more diverse data than you started with. And this reduces overfitting, improves generalization, and allows for building a higher performing model in scenarios where you don't have enough data. And this is something that has become instrumental for my company and myself to be able to do the stuff that we do. So what is topic modeling? So this talk is about how do we leverage LLM and to augment data for topic modeling. And topic modeling is an unsupervised machine learning technique that can be used to identify topics and themes in a large text corpus. And the key idea behind this topic modeling is that documents consist of multiple topics in different proportions, where each topic represents a cluster of words that frequently occur together. So when performing topic modeling, this algorithms analyze word co-occurrence patterns within documents, which allow you to discover semantic structures and extract meaningful topics. So you're looking at a corpus of text, and you can extract categories and topics based on this thing that you do. And as you can see in the picture, you start with topic modeling in one way, and you create topics based on this documentation that you have. And again, it could be used to kind of categorize and cluster different parts of your documents, and you come up with topics that represent those documents. And the problem we're trying to solve is, how do we solve insufficient data? And supervised models require large amounts of label training data, like I said. So you may have a small subset of data, or data you need to enhance to be able to leverage the supervised models to train them. And for many tasks and domains, quality training data is scarce, so you don't have enough of it. And even if you have enough of it, you might not be at the quality that you need. And this limits model accuracy and generalization. So again, when you're training a model, it's kind of hard to get a good grasp of generalizing on your context, because you don't have enough data. So one of the solutions that I've done is basically using large language models to augment data generation. So first, I collect initial seed of data set from an NLP task. It could be sentiment analysis, could be categorization, it could be topic modeling. So I collect small initial seed. I feed these samples with prompts from this data set into the LLM in a way that will augment my training data. And then I filter generative samples to remove low quality samples. So fitting the my seed data into LLM, get the stuff out and filter them out just to make sure that I have quality data. And then I add the augmented data to my original training set. And this is a pattern that I follow in some of the stuff that I do day to day, and it's been really useful in me to get better results. And this is an example that I created just for the presentation, in which I do have a collect initial seed data set for an NLP task. Let's say this is sentiment analysis, and this is a Hugging Face tweet evaluation data. And the tweet eval data set contains emojis, it contains a bunch of stuff, and one of them is emotions, which basically have a training data where it has a tweet and it has a label on it that you have. And I apologize for the some of the words that are showing up, but I just randomly selected from what that was. And the second step that I said, I feed the sample prompts from the data set back into the LLM to generate augmented output. So we start with a augmentation prompt in which you are a helpful writer that takes sentences and replaces with synonyms, but keep the sentiment of the original sentences. So if you can't think of any synonyms, just return the same sentence. And this is one of those things that is really useful to be able to leverage LLM in order for me to do augmented data. So again, I take the original text, which are the tweets that you saw. I add this prompt to say, hey, give me something similar, but with a different, maybe change synonyms or change something in it so I can use it as training data. And I do that into a large language model that allows me to then get more augmented data. And the next step that I put on the previous slide is to filter this generated data for quality. And in this case, some of the stuff that even got generated, one of the first things I did was to say, okay, give me the original tweet augmented with new data, but check to make sure that the new augmented data has the same sentiment than the other one. And even though the LLM might generate stuff that it's accurate and we as humans can identify the same meaning, you have to make sure that the data that you have is quality, because in this case, about 15% of the use cases were not the same as the original sentiment. And again, so the next step would be to filter those out. And then once we have that, then we have augmented data that we can see and we can use for training or for whatever we're using it. And again, we started with a simple text that has the original tweet, and then we augmented it with LLM and basically asking through a prompt, hey, you are a useful writer, I'm gonna give you a text, just give me the same thing, and you maybe change synonyms. And I only use synonyms for this example, but you can do things like change, paraphrase it or say it another way, but indicating in the prompt not to change the sentiment. And again, here again, if you read this thing, happy birthday, you for birthday, and things like that, it's pretty much the same meaning from a human understanding perspective, and the sentiment that it generated is the same. So again, this is the important part of the code. So let me show it to you in code. Yeah. So I do create it. I'm happy to provide this to you guys. Just send me a message and I'll send you the link to my repo. But basically, I started by getting the data, and again, just tweet eval data set, and I'm using the emotion parts of it because there's a bunch of them. And I'm using a subset of them. And this data set has something like worries, a down payment, when a problem has a tweet, and it has a label. In this case, the label is optimism, I think, here. And I only keep 300 tweets just for this exercise on this thing. And again, I have a text, original text, and I have a label in it. The next thing I did, I added a column on the sentiment to be able to compare me when I was generating the LLM text data, so I can see it in a way that makes sense. This is the distribution of the sentiments. The one thing I didn't do in the code that could be part of your augmenting the data is to make sure the data is balanced. In this case, we have a lot of anger and a lot of joy or optimism. And again, those are tweets, so it's kind of makes sense. But one of the things that we recommend you doing if you're doing this technique is basically make sure your data is balanced. And maybe I'll do that in another exercise. But for now, I just loaded the classifier just to kind of say, okay, classify these tweets so I can compare them against the ones that get generated. And again, I created a prompt that says you're a helpful writer that takes a sentence, replace it with synonyms, and give me the same, keep the same sentiment. And this part is as critical because the LLM will know that what you're trying to do is, okay, just change the phrasing for new data, but keep the sentiment. So when I train it, it basically gives me the same results. And again, Warrior is a down payment for you may never have. And then the LLM generator, and I'm using OpenAI's for this, but you can use many other. Anxiety serves as an initial investment and a potential issue that may never come to fruition. So I mean, it's similar to what the original intent was, but it's creating brand new data that you can use for training. And again, the classifier of the original text was number 2, optimism, and the classifier for the new text generated is core. And this is the part that, again, you have to check that the quality of your LLM generated data makes sense. All right, so basically I want to show you this. I generated the text, the augmented text on the other hand, and then I make sure that the data I created, I only use the stuff that is quality-wise matches the original intent. So this is a simple example I want to show you from using tweet data. I'm going to show you now how I use it for topic modeling, which is kind of like the main idea. And again, I just wanted to give you an idea of this is how you can use a large language model to be able to generate synthetic data that you can use for training in a downstream stack. And that was more for classification, but this one is more for topic modeling. And topic modeling, like I said, is basically the ability to assign keywords to a specific set of documents that you can classify them in clusters. And I use data from Open Food Facts, which has about 2.3 million products from about 182 countries. The data is open and it's free to use. They do give you either a CSV or they give you a MongoDB database. The step that I do here in this process, and I'll show you the code, I extract all the data. At first, I basically download it, put it into Mongo database. I extract the data. I remove common keywords. I use OpenAI again to generate synthetic data out of my LLM, and I'm using the basic, 3.5 turbo for this. And then I create a richer expression, richer sentences of what the product, what the food it's showing you. And then I used word topic, which is a way for you to do training a model to come up with a categories, topics within this text. Okay, so let me go here. So I use open foods like topping, and I use LLM to expand into rich synthetic data to generate paragraphs describing products I use this. And let me, but it's a few steps here. But the first step that I do is to start with a small seed data set, just like I did for the tweets. List of products, names, and categories that have. I clean that up a little bit. My next step is to use LLM to expand into rich synthetic data. So I start with something that might not be as clear from a quality perspective, but through an LLM, I come up with this rich and really well explained data that is based on my original data. And then I train a topic model, and then I use bird topic to cluster the descriptions to discover product groups and trends. And this is something we're doing similarly in my work, healthcare company, for some of the back-end search and recommendation systems that we have. So we have a small subset of data that we enrich for clustering, and then we use it for recommendations in the backend. But this one is using the Open Foods facts data set. So I start with a small data set, and again, the data has about 6,000 columns. So it's a bunch of data that you get from open source. Some of them is incomplete, some of them is not there, and some of them have unknown stuff. So the idea for leveraging LLM is basically how do you go from having data set that might not be as rich and as complete, um, to something that makes sense for a clustering. And again, this is kind of like I collected raw data as a pandas data frame. I just get the row, convert that into a dictionary, and a dictionary might look something like this, which has a again labels, maybe a language, and some something about ingredients and some creator and some brand. So it's all this like not really concise and kind of all over the place information that I get. So I get this information and then I use another prompt to expand it into rich synthetic data. And again, I generate paragraphs describing the products in a way that has more quality than the original data that we have. And in my prompt that I use, and I'll show it to you in 1 second, you are a helpful text creator that takes incomplete information about a food product and create a well-written explanation of what you're giving. And again, so something that is not as complete. And I kind of give an example of this, and I say something like, you might giving a product that says product name and some name in it, might be comma delimited, might not. And one of the main takeaways from this when you're prompting your LLMs is make sure that you also tell it what not to do when it couldn't find information. And this is something that I found, because sometimes if you don't tell it, if you don't know the answer, it will give you like random stuff, code, or like it will go hallucinate things that are not there. So I basically specify that if you can't create the information, just write no information from, because this part you will use it for again for being able to signal and filter the quality of your data, right? And there are other prompting techniques you can use in context learning. Give an example, chat-based prompting, only a few examples to give it to as well, or chain of thought prompting, which again you can go step by step. In this case, I kept it simple and it was good enough for what I wanted it to do. So once I have created my my data set, I look through filter for anything that's not correct, and I look at the quality, and I feel that it's good enough. I then use BERT topic for the training. And the cool thing about BERT topic is that it's kind of like a way for you to do multiple steps on training this model to give you topics. And each one of these components you can change. So the first thing you do is the vectorization of your text. So you put in your base data, you put it into an LLM. The LLM gives you synthetic, richer quality data, and then you create embeddings, which basically is representation in a vector space that allow the model to be able to cluster them better. So that's the first step you have, and you can use as BERT. You can do a bunch of other. You can use your own model that you have, your language model, to do the embeddings, to be able to do this thing. The next step you have to do is do dimensionality reduction. So you have embeddings that would be 10,000 or 700 length, and you can use those out of the box. But the larger your embeddings are, the harder it is for you to cluster them. So the first thing you have to do is to make it smaller, without losing some of the representations that it come with, and that's where UMAP comes in. And then we do a clustering of those things. So there's something called HTTP scan, which is similar to k-means, but it's more for spatial clustering. K-means is more like it's simpler than HTTP scan. HTTP scan is great for things that might not be as related as thing. And again, text, you have this dimensions in the vector space that might not be as easy to cluster, but HTTP scan does a good, it's an algorithm that you can use to be able to cluster them better. And then the last part of our topic that it does, you tokenize everything and do TF-IDFs, which is basically cutting keywords in a way that you match keywords that are related. So the good thing about BERT topic is each one of the steps you can swap by something else. You want to use k-means, you can use k-means you want to. If you don't want to use a conv vectorizer, you can get it off and you can just use a TF-IDF. So it's really modularized in a way that it's kind of easy to use, and that's why I like it. And we use it for more topic modeling. And the last thing you do is just basically come up with a topic. So this is an example of BERT topic giving you clusters and descriptions to discover groups of trends. And again, this is from my open food data set. And you can see that the first topic has cheese and dairy and milk and creamy. So you kind of determine that these are related in a way that makes sense. Chicken, tender, meal, meat options. So again, they're kind of related. And again, these are the the bird topic, looking at your data set and automatically coming up with this topic is based on the embeddings and based on the presentations that it does and all the stuff that it does. And this is the output, and you can use this for either search or recommendation or some other downstream stacks that you use it. But again, it's a really powerful technique to be able to go from data that is not that well written, data, to enhancing it with an LLM and then creating clusters using bird topic. So let me show you what that looks like this in code. I know we have a few minutes left, but let me show it to you here. Back, second screen. And again, the first thing I do is to get the data from OpenFFX, and I guess I have my local MongoDB database. I extract the text data, I filter it for common keywords that I know might not add to the quality of the data set. I put it through OpenAI, the LLM, to leverage that part of LLM to create text. And then I come up with product definitions, and I do topic modeling for that. And an example of this thing, so this is like a record that has information, and again, 6,000 columns you get for each record, which is a lot. And the first thing I do is convert this thing into text that makes sense, text that are human readable. So I go from having all the 6,000 columns into extracting things that I know could be bare minimum for us to understand. And I also eliminate things like test, web, full calories, and things that I know that will be repeated across my test set. This is an example of a record that comes out of just the raw data that I have. Again, just eliminating simple stuff. And then you have countries and categories and nutrient. And again, the good thing is it's a really rich data set. The bad thing is not that complete. But out of this, I clean out the common keyword values. So I only end up with something like this. So each one of these things represents a record that is the raw data. And this is what I feed to the LLM. This is what I say, hey, this thing is called, product name is called Virginia Brown Ham. These are the keywords that it has in it. This is some owner that it has. And then I ask the LLM to generate text on that. And again, I have my prompt. And my big takeaway of the prompt, make sure that you are as specific as possible. If you can give it examples, give it an example to the prompts, but also tell the prompt, tell the LLM what you want, if not information and so on. This is kind of key to be able to filter out later your stuff. And this is, again, an example of going from something like this, which has a simple, really incomplete information, to coming up with something that says, okay, Very Value offers a product called da-da-da, and it describes in detail the stuff that this product is about. So this is the using the LLM to generate quality synthetic data. And again, this is really good for topic modeling, because the end product is just basically coming up with the clusters, not anything else. And it's really useful because the LLM getting simple data like this is able to generate a really cool data set for this. And then I save it into a local database, and I basically just use it for my bird topic. And the bird topic code, I'll show it to you. Also, again, I read the data, and this is the data that we have. We have a simple text in one end, which again is limited, is based on my raw data set, it's based on me cleaning some of the stuff. And it comes up with a generated quality data that is with better quality than where you started. And it's pretty good at describing the product of, this product is called the Valley Pulpy, and kind of describing what it is, a beverage, this thing about cheeses and creamy. It's a creamy light spreadable cheese. And again, this is kind of like the magic, and like the big takeaway is like you can use an LLM to start with simple non-descriptive data to something that is really useful. And again, I clean a little bit to filter the data that is not, if the LLM didn't find any information, I filter that out. And again, this is a sample of some of that data that got generated with the training set. I build the bird topic model, the UMAP section, and you can tweak some of those values, the neighborhood, and the components for it. I do the HTTP scan step, which again, it does the clustering side of it. I do the embedder step, which is the embeddings. And then I can basically create my bird topic with all the stuff that I created. I had a convectorizer, and I do like a representation model to kind of fine tune it at the end. And I just train it, and it's, trains my model. And one of the things that I use for measuring performance topic, I use something called coherence and diversity. And coherence is basically how interpretable the keywords are. How do they make sense? That's basically coherence measures. And the diversity is how diverse are the keywords? Are these keywords being repeated all over the place? So the two scores to keep in mind is a coherence score. The higher the better, and diversity, again, the higher the better. And again, for this stuff here, uh, out of the box, just tweaking a few parameters by using LLM generated data, I get a coherence score of 0.943, which is pretty good. The maximum is 1. And it's telling you that this topic modeling that I created, it was really good at doing topic modeling because of the data that I fed. And just again, to give you an idea, the other one, and it gives you distance map, and again, this is bird topic giving you clusters, and you can look at it in a map, and you can see the actual topics, each one of them, in this kind of cool way to do it. And again, chicken, tender, meal, meat, you can kind of see related, and how it tells you how probability of that being the case for the topic. You can also cluster your topics in a way that you can see everything in one place. And I'm just going to show you real quick training the same model, but not using synthetic data. And again, just using the raw data you saw, the simple product name, maybe some cute labels, that are incomplete data. And it gives you something, but some of the stuff is not that well represented, because again, you don't have enough information for the topic modeler. Some of the stuff is not that bad, but some of the stuff like product name, that doesn't really make sense for a topic perspective. And again, you can see the map here, but the score, I didn't put it here, but the score here on my next slide, just to show you,
I
is
will
that,
just very quickly interrupt you.
yes,
Thank you so much. It's extremely like useful and very knowledgeable. You have a lot of information here and present
yeah,
that greatly. That's our last talk for today. So we have some extra time. So please feel free to use about like the next 15 minutes or so.
yeah, absolutely. And again, this is the modeling metrics that I came up with. And again, the coherence is much better with synthetic data than without synthetic data. And again, it's in a way for me to want to show you how you can leverage LLMs to be able to get better quality data for topic modeling. All right. Any questions? All right. Well, hopefully you found it useful. I'm happy to share the slides later on. Camila, let me know how, and happy to share the code as well. But thank you for the opportunity.
Yeah, totally. Thank you for this talk. Actually, I have one question,
Yeah.
about the production use of that. Like, is it
Yeah.
something which which you are using in your work, or like how people are using that?
Yeah, so this is something we use in my own company in the back end. And we use it to classify some of the documents that we have in the back end. And we use this process to augment the data set to be able to build a better recommender. And we have a recommendation system in the back end that uses a bunch of data points from our data set. And one of those data points is topic modeling. So the categories that we have for the topics. And instead of us or even having to label it by hand, we're feeding into a system that the output of it are topics that then get used in a recommender system in the backend.
Oh, wonderful. Yeah, it's always really cool to see that in like how companies are really using that, and I believe that we'll have that more and more in the future. I see some question on the chat.
Okay.
How do you convince the customers to use the models by using synthetic data that might not represent real population data and introduce some biases?
Yeah, that is a good question. And that is one of the steps that I kind of went really fast on it, like filtering the one step that you have to make sure you have is the quality of the data set. So once you generate your synthetic data, you have to have measures in place to make sure that the quality of it is it's legit and it works. In the tweet example, I basically say, does it match the original sentiment? That's like the simplest thing you can do for quality. In our own system, we do have checks and balances in the backend. We have models that detect when a text that is generated it's not coherent or it doesn't represent the medical stuff that we're trying to do. And again, our use case, we don't none of our data sets that we use synthetically are for end use. We use it for internal recommendation systems, which they've become better. But yeah, you have to have a bunch of if you're gonna use this data set for anything related to you, if you go for that for training data, you have to make sure that you have a few steps of quality control, and imbalance data and biased data for sure on it. So yeah, good question.
Wonderful. Thank you for this question. Thank you for the answer as well. And technically, one information for you, Ariel, in terms of the slides, we'll be collecting slides on a Google Drive. So I will send you the link for the Google Drive, and it would be great if you could just upload that there. The recording from the stock and from other talks and workshops we'll start working on that next week, and you will get the information when that will be published. Perhaps it will be published on the PyData YouTube channel. And yeah, do we have? Oh yes, we have another question.
Yeah. Why is ATV scan over DV scan or k-means or clustering? Yes, k-means can be more efficient for larger data sets. I think it's just a great question. The problem with the k-means is that it's not really good with spatial data and data that is really vectorized in a way that have this huge dimensionality. So k-means is great for like lower dimensionality systems. ATV scan is for things that might not be that might have a lot of noise in it, and that's why ATV scan is one of them. But again, BERT topic allows you to swap some of the stuff that you have. You want to use k-means for clustering, you can, no problem. And this is part of this is the science of power of data science, right? You get to play with that. But yeah, good question.
Wonderful. Okay, so do we have any other question? Yes, we have. How do we present bias and unfairness in these cases in this LLM systems?
Yeah, and again, this is one of those things that is really a topic for a longer discussion, a longer presentation. But the quality step, the filtering step, is really important depending on the downstream text that you have, right? And I think that if your data is biased from the get-go, your synthetic data will be biased as well. So that's one of those things about using large language models, that if your data from the beginning is biased, you have to have checks in place. You have to have quality steps to be able to prevent that. And again, you can do perplexity, you can do other scores to be able to measure how well it represents your data set. But it is one of the challenges you do. And with some of the stuff that I see on the AI side and data science side is using models to basically detect stuff like that. Be models that are trained just to detect anything on the data set that are biased or that are imbalanced, and then using those as a filtering step before you can reuse any of the synthetic data. It's a good question.
In terms of bias in AI, the term many like checklists created, for example, from Microsoft and from other companies. Also, some research entities also create that kind of checklist, which helps with AI on the on that starting through with data. Everything starts with data. Are you familiar with do you maybe have your own checklist? That's my follow-up question for you, Ariel.
So yeah, we have techniques, but not for the bias side of it. We have techniques for the quality side of it, which is again, when we generate data, we need to make sure that it's appropriate and specific for what we are doing. And again, we do have like a couple of steps that we do, like medical checks, like, hey, this generator is, let's say I'm generating data for a specific Tylenol, and I say, give me a synthetic data for describes Tylenol, and maybe something like, hey, Tylenol is great for headaches or pain medicine. So we have keywords that we extract from the synthetic data to kind of signal the quality and kind of like measure that. But yeah, that's how we use it. We have steps for that, for medical specific, not for bias.